All right. Morning. All right, so looking at a few number lines here, if I were to graph G is less than or equal to -2, I would go to -2 and put a closed circle because that equal to symbol. And if it's less than -2, I'm going to squiggle. And that's literally the verb that I use. I'm going to squiggle the side that is less than -2. Okay. All right, so F is greater than 0. So I'm going to go to 0 and put an open circle. It does not include 0. It's greater than. We're going to squiggle the greater than side. That's fine. Yeah, so some people do it like this. You kind of, do you have the open circle and then you go like that? Right? Sure, sure. Now I always throw in this last one because the variable is allowed to be on the right side instead of the left, right? So all of a sudden when you read this one, you can get a little confused, right? My brain, and I'm a veteran, you guys, I've been doing this a long time, but my brain, if I tried to read it as 2 is greater than or equal to K, that's confusing for my brain to try to graph. Does that make sense? So I always want you to read the inequality, start at the variable, and then read it either left to right or right to left. Just depends. So here it says K is less than or equal to 2. If that's confusing for you, you can do what I used to call pull the switch. I'm going to switch the K and the 2. And if I rotate those, I have to rotate my inequality to match. And this one might be a little bit easier for you to read. Again, if you just start on the right side and work your way over, some of you won't need to do that switch in order to see it. But if you have to, that's why I'm showing it to you. Okay. So I kind of double check myself whenever I rotate that. If the mouth was open towards the 2 before, it needs to be open towards the 2 when I'm done. Okay. And now I can easily graph. K is less than or equal to 2. So I'm going to go to 2. And I'll go ahead and do the arrow this time, just so we have some options. Is that how you do that? Or sometimes you put the arrow on the number line itself. I'm not going to because I'm using pencil. It might be hard to see. Okay. All right. So I want you to graph these two inequalities real quick and tell me what these bottom two represent. And if we're good, we will move on. And when you're ready, just take a peek up at the board and make sure you have the matching graphs and description. So again, a little bit tricky on this one. I just went ahead and switched the sides to make it easier for my brain. Any questions there? Kind of coming back to you, right? All right, so let's start talking about the difference in solving an inequality versus solving an equation. There really is one special rule that we're going to talk about. One special case. And it doesn't even appear in every inequality. And that's something you just have to keep an eye out for. Does anyone remember what I'm talking about? That's all right. Okay, so write this down. Oh, let me see, how do I want to word it? Okay. When you multiply or divide by a negative, you must flip the inequality symbol. Excuse me. When you multiply or divide by a negative, you must flip the inequality symbol. Now, this is one of those things where I used to think it was kind of hard to explain why we do this. And I always love that challenge of a student asking why, like, why do we do that rule? And I actually have a good way to explain it, but I want to do a basic inequality problem first, then we'll show you the special rule. Okay, because there's really more than just solving an inequality. You have to graph its solution. So I have a couple like shortcuts, special circumstances, things I need from you whenever you make a number line. So we'll start with just a regular example. We're going to go super basic, two-step inequality. Really, our curriculum asked me to do one day of one step and one day of two steps, but I do think you guys are completely prepared to just go to two. Okay, so we're going to solve this like normal. We're going to subtract 7 from both sides. 6x is greater than 12. Divide by 6. And x is greater than 2. We're not dealing with that negative. We're not multiplying or dividing by a negative right now, so we don't have that special case. That is not a solution that I need more from you, I guess is what I should say. So we have to graph every solution of an inequality that we have. So I want you to draw what looks like the start of a number line. And here are my shortcuts, okay? We have to put the number 2 on there because that's like our go-to number for this inequality, right? We have to show 2. So I always put that in the center. And then I want at least 3 numbers on either side of that golden number, if you will, okay? And I don't need your number line to be any more detailed than that. Okay, so let's go ahead and graph that. We have a greater than 2. And put this open circle, and squiggle the greater than sign. One student noticed a couple years ago, I guess I can't really move, that this symbol was almost like an arrow pointing in the direction that squiggle should be going. I don't know if you've ever noticed that before. Where that's not true is when it's written backwards. Okay, so I want to caution you against using that unless the variable's always on the left side, and then that strategy actually always works. Okay. All right, so let's look at that special case. Number 2. Let's do x over -2 plus 8 is greater than or equal to 10. Spencer, what's my first step? Yeah. And just because there's what looks like a -8, that's not our special rule, right? We're not multiplying and dividing it. All right, so our next step is to, multiply by -2 to make that -2 disappear. The second I kind of say that to myself in my head, that like warning should be going off. We're multiplying by a negative. Therefore, my inequality symbol literally rotates. If it was open to the left before, it is now open to the right. X is less than or equal to -4. So let's graph that, and then I'll show you why that happens. -4 in the middle. Is a closed circle. And the less than